Okay, looks like we are live. Of course, let me go double check that. Make sure we are working. Oh yeah, looks like it. Okay, perfect. So, first of all, happy Thanksgiving, everyone. I hope everyone is having a wonderful, or getting ready to have a wonderful holiday. Luckily, it looks like that overall. Oh, wow, look at that. I got one hair that's sticking out. What do you know? Well, first of all, got the mug here for NY and JPA weather. It's pretty cool. Keeps everything nice and warm. I got coffee in there. French vanilla. Actually, no, I'm sorry. It's a caramel. So that's caramel vanilla. We are decorating the Christmas tree. We have the Christmas tree up. We're working on that. It's off to the side over here. We normally don't do it this early, but we're going to be busy this year, and it seems like everyone's decorating early, right? So it's pretty crazy in that respect. But yeah, I want to first wish everyone a happy Thanksgiving. It looks like, again, the travel conditions won't be too bad. Some interesting things that I've been noticing. Premium members know I've been going over some of this stuff. So I'm going to go over the long-range data and just kind of point out some of the changes that we're seeing, the trends that we're seeing, and the potential for maybe a little bit of snow. Although I'm not, bless you, I am not all that impressed yet with the setup, but there are some things that definitely have caught my eye. I mean, of course, tonight we're going to go over everything I'm seeing, and then I'll take your questions, so definitely load them in there. Those of you guys following on YouTube, of course, we'll take the best questions out there, and I'll answer a few of them. Everyone who's a premium member gets all their questions answered because you guys are premium members and you're awesome. Thank you. And everyone's awesome. So there we have it. And, of course, if you're interested in becoming a premium member, check out nyandjpaweather.com. And there we go. So I said all that stuff. Now let's talk about some interesting data that I've been watching. This is the European Ensembles Guidance. I want to walk you back first and take you back to the 22nd 12Z. And this solution, which is loading right now, was pretty warm. Okay. Actually, even further back, the 00Z from the 22nd was suggesting this pattern here would be basically a torch for the eastern United States. In fact, if we go look at 850 millibar anomalies, yep, that's pretty warm. Right? And everyone's screaming winter over. By the way, winter's never over in November. Okay? So everyone was saying that, and there was a lot of great concern and a lot of gnashing of teeth and wailing. And then, as we move forward, we started to see fundamental changes in how the model guidance was handling this time period. So first we had a deep trough in the west and basically a broad ridge along the east coast and another ridge complex around Texas. Notice we had a block here around northeastern Canada. Then the 12Z guidance, and we're sticking with just 0Z and 12Z. Can everyone hear me okay? Make sure everyone can hear me. I just saw... Okay, it looks like everything's good. Okay, Card, you might have to reset your screen or your, because it looks like everything is fine. Okay. Everything's good on your side, babe? Okay, good deal. All right, so where was I? Okay, so then we go to 12Z from the 22nd. Then we go to 0Z from the 23rd. And notice the heights are starting to fall here. And then we go to 12Z, even more aggressive. So what is happening here? Okay. The reason why people are saying torch, torch, torch is because they keep on using the GFS. Stop using the GFS. Please, for the love of God. Let me show you why. Okay, so let's step back and go back to the general way of forecasting. Okay, observational base. What are we seeing? Observational wise, we're seeing convection keeping on trying to linger around the date line. So it's kind of a hint. Hey, there's a forcing mechanism here. Why is there a forcing mechanism here? Well, it could be because La Niña, which is right here, is clearly east-based. And we'll go over some of the data just to prove that point. So we have east-based La Niña, and we have a stronger thermal gradient here towards the date line. We also have a pretty strong negative PDO signature, right? Okay. And take a look at our, what? Oh, that's okay. Where was I? Okay. And then we have the La Niña signatures. This is 1 plus 2. This is the coldest signature, and it's the furthest east. Niño 3, around 1. Niño 3.4, it's a little bit warmer. Niño 4 is the warmest. So I think we made an established case, east-based, weak La Niña. You go by the La Niña strength by two ways. One, what is 3.4, which is at minus 0.8, and also the SOI data. I like using, as I've discussed before, I like using the SOI data because it gives you a true connection between the sea surface temperature anomalies and the atmospheric forcing. Okay, it's the pressure mechanisms, right? Because the stronger that pressure gradient, the more you see the convection, the wind movement, everything's connected to the pressure. And so when you have the SOI values around 8, 9, that's weak. That's a weak signal. So we got that, right? Meanwhile, we are seeing La Niña pretty much at its strongest. And now it's starting to weaken. How do we know it's starting to weaken? Because the support at the subsurface is weakening. Notice the trend through November is that as this cold air is lifting up towards the surface, it's moderating at a steady rate. Now, that takes us to the MJO. This is the GFS. It was all over the place. Now it's starting to get an idea of, now it's trying to go through 4, 5, 6, 7. Okay, parts of it's trying to just go into 6 and 7 phases. In other words, it's still kind of all over the place. This is another solution where it's split. Then you got the CFS, which is just completely lost. And then you have the European guidance, which takes you from a neutral state to phase 6 and then heading towards phase 7. And then long-range guidance through the middle of December takes you through phase 7 and 8. Phase 7 and 8 are active cold weather patterns for the eastern United States with the MJO. So, we have a better idea what the tropical forcing mechanisms would suggest. An east-based anomaly. It would suggest generally a weak subtropical jet stream and an amplified polar jet stream. Okay, that's what these things usually support. The east-based orientation would support a ridge closer to the Bahamas and Cuba than, let's say, the Gulf Coast. So these are all attributes without looking at any model guidance, okay? So, and I'm walking you through this so you understand why the models are doing what they're doing. I can show you models all day. It doesn't mean anything if you don't understand what the forcing mechanism is behind it. So, We have that. Then we have what is going on with the tropical force, with the stratospheric forcing. Now, right now, we still have transport coming from the troposphere into the stratosphere and still supporting the potential for disruption. But we are seeing a significant cooling event right now, which is kind of, you would expect that after having a massive warming event, you kind of get a rebound of a cooling event. This would allow the polar vortex to strengthen. But as you can see with the observations here, we continue to see a lot of warmth here bubbling up here around the tropics. The only thing you need to do is start to get this transported northward, like what we'll see right at the end of this feature, right there. See that? That's the start. That is the start of the disruption. The very beginning, an infant. They're very, very small, okay? So there's the start that I'm looking for. Meanwhile, all your ozone buildup is around the Pacific. So when something gets going, watch out for that negative EPO to pop. So those are the observations I'm looking at, right? And so I'm looking at all this stuff and I'm saying to myself, there's got to be some other mechanism I'm missing here. What would cause the heights to go below normal like this in transition, right? And again, follow me here just because this is going to explain why we're seeing what we're seeing for Sunday. So let's go to the Northern Atlantic. This is a lot of warm water here. And despite what you might have heard, the Gulf Stream, or the AMOC, is not anywhere near dying. Okay, it's very much alive and very much strong. So this is all well above normal. You got a lot of warm water and you have polar air masses interacting with all this warm water. So as a result, you have all the forcing you need in terms of thermal gradient to support rapid cyclogenesis or low pressure system development. So you have the forcing mechanisms that would eschew a normal La Niña event to the east, allowing for more below normal heights over the Great Lakes and the Mid-Atlantic. You have above normal water temperatures that would support low pressure system development. All you really need now is for the Pacific to start falling into alignment. So when you have all these forcing mechanisms, that is how you start seeing this evolution. Where you go from trough after trough, redeveloping here, producing low pressure systems, basically producing storms for the Gulf of Maine here. But as they swing around, this is how you kind of get your clipper situation. This is essentially a clipper pattern. Then as that evolution continues to feed back on itself, you start to support a broader trough and more blocking starting to push up towards Greenland. And now you start to see the polar vortex drop south. You have your upper level, you have a nice deep trough here around the west. And so this kind of reminds me of what we saw in 2011. In fact, I think someone mentioned that real fast. This screams to me of an Arctic air mass in December dropping into the Rockies and northern plains and then bleeding its way eastward. And as it's bleeding its way eastward, we get clipper after clipper, and you start getting this stationary front here with waves of low pressure and just a mess setting up in December. So I'm definitely seeing everyone's questions. I'll definitely be answering them as soon as I get done with this little dissertation I had in my head. So with that being the case, with the lifting parameters we're seeing, that's why we're starting to see this general shift. But the GFS, because it's not doing a very good job in seeing what's going on with the tropical forcing, it's not doing a very good job with handling mountain torque. Don't even get me started on the AAM. It's not doing a good job handling these features. And so as a result, it's producing solutions like a strong La Nina, all right, via the CFS parameters, which is complete bunk. So as a result, it's creating a lot of this blowtorch idea, which simply isn't supported when you look at the observations of what's going on. So that brings you to this evolution at 500 millibars, where this is not a pattern that is stormy. This is not a pattern that is, that's not the right word I want to use. This is not the type of pattern that will produce major winter storms or major rainstorms. This is the type of pattern that produces little pests that pass on through, producing scattered rain and snow showers. Every so often you get a period of light snow popping in there, like what we're seeing here showing up on Sunday. I would stress, do not bother looking at the snow maps yet for this time period, for Sunday night into Monday. We're still too far out, but just keep it in the back of your mind during that time period, scattered snow showers, okay? And the reason why you don't want to jump the gun with snow maps is because this part of the evolution here strongly depends on how strong this shortwave is and how much it interacts with the ocean. So if the timing is just a little bit off during this evolution, this part of the evolution where you're having the precipitation shield grow, then it could just lead to just a couple of flurries, or it could pull in too much warm air at the lower levels. It's also moving through at the perfect time in the morning, in the late evening hours on Sunday into the morning on Monday. So it allows you the opportunity to maximize cooling. So if any of those factors change, then basically you get nothing. So the forecast is showing up there on the European of like 1 to 3, 2 to 4, somewhere in that ballpark. Excuse me. That would be jumping the gun. We have to wait a little bit. It's really hard climatologically to get that type of snowfall on the coastal plain because the water temperatures are typically a little bit too warm and warms up the boundary layer. So instead of it being 33, it ends up being 36. So I'd wait on that. But I like the general idea of the pattern, which is active with a lot of pesky little low pressure systems rotating through along with cold fronts. And then the interesting part for December is that as this pattern evolves, we're going to be dealing with two different types of forcing mechanisms. One is what we have right now with the feedback in the Northern Atlantic, which is supporting the short waves diving south through us. And then the Pacific becoming more favorable by the middle of December, coupling with this pattern that we're seeing in the Northern Atlantic that has the potential of creating some very interesting evolutions in the weather pattern. And yeah, winter storms. So I'm very, very interested to see how all this comes together by around, I say December 20th. We might be seeing a very interesting pattern evolving over the eastern United States. We'll see. We'll see. Again, a lot of this has to do with timing, and we're going to have to watch this week by week. So as far as travel for Thanksgiving, and I'll take your questions over the next 90 hours. I'll pull that up. And it is pretty quiet. The lake effect snow pretty much comes to an end. It's quiet all the way until we get to Friday morning with the weak cold front moving through. But, well, not weak. The cold front itself is strong, but not much in the way of precipitation. Do keep an eye out on Friday afternoon and on Saturday for some lake effect snow showers and possibly even some light snow for the Poconos and Catskills. So that is everything that I'm seeing right now. And now what I'm going to do is go back and answer your questions. Now we're live. There we go. All right. I'm going to have some coffee. I've been going over all that stuff. And we're going to answer the premium section questions first. And then we're going to go over and see what's going on YouTube. So we'll answer the best questions on that. I drink my coffee. Let's see here. Let's see. took a look at Earth News School. 10 millibar feed from the tropics into the polar regions is even stronger this week. Well, let's take a look, shall we? Would it help if I pull up the screen here? And we'll go to 10 millibars. We'll do HD. Let's zoom out. A little bit too strong. There we go. Oh, yeah. Yep. There it is. There's our evolution. Now, what we're going to want to see is that as this transport intensifies, what we're going to be looking for is a pocket of warm air to start to get transported basically right around here. Okay, so we're starting to see some inklings of it taking place right here. And what we want to see is a pocket of very warm air at, let's say, about 70 millibars, grow in strength at 50 millibars, and just become a powerhouse at 10 millibars, and basically hit this polar vortex like Mike Tyson, okay? And just split it or severely disrupt it. That is what we're looking for. And I'm seeing some indications that might just be the case. But we have to wait and see how it plays out in the observations. The GFS is spinning up a monster hurricane nor'easter twice a week not too long ago. No surprise it is way off. Well, I know that they're working on improving the GFS, and they are. It is getting better, comparatively. But it has some, in my opinion, has some severe problems with its convective feedback, which leads to a lot of erroneous solutions. This is why you see a lot of solutions in the GFS where you get these monster winter storms and then they disappear. Now, to be fair, the European sometimes has these issues too, but they typically don't last as long, and they're usually corrected very, very quickly if you use the ensemble guidance. I think that's the key here. The ensemble guidance is what you want to use to look at the overall pattern. And if you use the ensemble guidance, yeah, you get a couple of weird runs in there, a couple of errors, but the overall theme with about 53 different models blended together usually gives you a pretty good idea of what you're looking for, and it allows you to match up with what's going on in the observations itself. Let's see here. Denny Cox asks, hey Steve, quick question. So based on the observations overall, how do you think the summer plays out overall as far as temperatures and precipitation? I think that precipitation is going to, actually temperature, I'll start with temperatures first. Temperatures are going to be a roller coaster. In La Nina years, polar and Arctic air masses typically are transient, which means they come in, they punch you really bad, a really, really strong punch, and then they start to moderate and pull away. And as that pull away happens, that's when you typically get your major storms in La Nina years. So I expect December to average near normal. I expect there to be some pretty impressive cold shots, but also some pretty rapid moderation events as well. I think that the northern Mid-Atlantic is going to be in a battle zone between a continental tropical air mass over the Gulf Coast and the Arctic air masses that are going to be locked in over Canada. And we are going to be fighting in between. As far as precipitation is concerned, I would say near normal overall. I don't see above normal just yet. If we start to lock in where we get a sustained negative NAO pattern, that might skew more towards above normal precipitation. And Denny asks another question about what exactly is a Kelvin wave? I hear you talking about it from time to time. What exactly does a Kelvin wave do? Oh boy. You know what? I want to make sure that you have a proper understanding. So let's pull up Kelvin wave. Okay, so let's see this. I like to use this to jump out of Google and pull this up, because if there's anything erroneous in here, I could point it out. But usually, something from the National Weather Service is pretty good. So a Kelvin wave is a wave in the ocean or the atmosphere. Now, they're both medians of basically liquid. Okay, the atmosphere is a liquid. Okay, it's liquid base, right? So a Kelvin wave in ocean or atmosphere that balances the Earth's Coriolis force against a topographical boundary such as the coastline, or as wave guides such as the equator. Another solution is a Kelvin wave is a wave in the ocean or atmosphere that balances. Yeah, same thing. Basically, the idea is this, right? It is the way for the atmosphere to balance itself out. And the wave, just like you would see in the ocean, where you get like a swell, right? Kelvin waves can have a variety of different impacts on the median that it happens to be in. They can occur in the atmosphere via a shortwave trough that can amplify a pattern, or in the terms of the ocean in enhancing La Nina or El Nino, for example. So there are ways in which, for example, the Kelvin wave that has passed through La Nina right now has enhanced it, has caused this cooling that we're seeing, which we can see right here in 1+2, right? Pretty aggressive cooling, even more so in 3. See that drop? Now, once it passes, you start to moderate in the ocean. Why? Because much like a wave, it crests and leaves. So it's a way for the atmosphere to balance itself out. Let's see here. Do you see the potential for the Pacific pattern to also get caught in a feedback loop? Not yet. I don't have any data to support that just yet. But there are certainly indicators out there that if you can lock in an upper level low right around the Aleutian Islands, which, let me pull that up here real fast. Let me pull up a map here. Yeah, this will work. Okay. So if you can get a feedback process to take place right around here, then you can end up with a block here that sets up, that feeds back on itself. But it's really difficult to get that in a La Nina year. Is it possible? Yes. Would I be looking for it? I'd have to see some change. Everything would have to fall together in order for that to take place. Let's see here. Rob asks, let's see. I see you want to stay on the tip of your tongue Boxer Day too, but I'll wait another week to hear it. Oh, man. Okay, I'll put it to you guys like this. I wouldn't say Boxer Day type storm, but I would definitely say this, that we need to be very much aware of what our clippers are doing and whether or not they might be redeveloping off the mid-Atlantic coast. I'll put it that way. But I don't see Miller A storms being an issue this year. So is the pattern evolving better to make it align better with your winter forecast? This is from Robert Whitaker. It's definitely moving in that direction. Okay, I knew that it wasn't going to do a snap in. Okay, I knew that there was going to be an evolution period. And remember, we're still in November, guys. So this the progression is where I want it to be. If I saw, let's say, La Nina stronger in Niña 4, that'd be a warning sign for me. If I saw it where 3.4 was supporting anomalies that are like 1.5, 1.6 below normal, that would be an error. If I was seeing no indication whatsoever of any transport of warmer air from the tropics and the troposphere towards the stratosphere, that would be a warning sign for me. So far, I've seen none of those warning signs. I did expect the polar vortex to at some point strengthen, because it's really, really difficult to get a weak, disrupted polar vortex from the fall all the way into the spring. It's nearly impossible. I think the closest I ever seen anything like that was 2009, 2010, where we had a historically negative Arctic oscillation. And then there was 2010, 2011, where that rivaled that. But even in that case, you didn't have a disrupted, split up polar vortex for the entire fall and winter. So definitely I expected the strengthening. Now it's the question of when do we see the weakening? And I think we're starting to see those signals. Matthew Myers asks, is it true that high-level blocking is now showing up more south and east than what was originally expected? And if so, how does that change the forecast? It kind of depends on what you were expecting south and east. Overall, from my expectations, I've pretty much seen what I thought I would see so far. So from what I was expecting, I'm not seeing anything further north or south. I am seeing stronger support for a upper level low remaining sustained around the Canadian Maritimes. And let me show you why that's really important. I'm going to go to 925 millibars here. Okay. So we'll load this up real fast. See, here's the thing. Every time we get an upper level low setting up around the Canadian Maritimes, what that does is allow cold air from the Hudson Bay to get pulled down towards the coastal plain. So the more that we see these upper level lows spinning about, the more likely we get that colder air to get pulled down towards us. In waves, again, with La Niña, nothing is ever sustained with these cold air masses. They're transient. But it keeps on getting pulled down. So it tells me it sets up an environment where you're more likely to get that feature around Maine, around the Canadian Maritimes, which leads to a better support for getting cold air pushed in while the southern Mid-Atlantic remains mild. So I'm definitely seeing more support for that, but I'm not seeing anything that is unusual or anything that I wasn't expecting to take place. In fact, in the winter forecast, I did mention that if we see this signal becoming sustained, you're more likely to end up with a colder, more active winter for the northern Mid-Atlantic. But also notice in the winter forecast, I separated out Baltimore and Washington because of the type of this storm, of these storms being Miller B type storms. Typically that redevelopment happens around the Delmarva Peninsula, which means by the time it gets its act together, it's pretty much in Philadelphia on northward, and Washington and Washington D.C. and Baltimore tend to miss out in those events. So that's why I did what I did with the forecast. Do you see any storm potential towards the end of next week around December 1st? You must be talking about, let's see here, let me pull up the data here. December 1st. Well, there's certainly a lot of short waves. I think that the pattern itself is more likely to support low pressure systems popping off in the Gulf of Maine and to the east of Long Island, supporting scattered snow showers. I don't see this pattern as a major storm pattern because the setup off to our west, which, let me pull up 300 millibar winds here. You see that signal right there? See this? This tells me that anything that tries to form over the East Coast is going to get kicked out. See, what you typically want to see with a major storm is for this jet to basically buckle, and you get this very strong ridge, and then you get a deep trough. And that allows for this trough axis to be closer to the coast, which leads to major storms. In this scenario, the trough axis is pushed out into the Atlantic. You get your major storm out here with your divergence and diffluence right here, but you don't have enough time to produce strong cyclogenesis along the East Coast. What you just get is a lot of snow showers. So what I want to see is this actually starting to show up at basically 10 days out. So I wouldn't trust the details just yet on this. But what I'd want to see is for this trough to start to dig, this ridge start to build, and that leads to a broad, deep trough over the eastern 2/3 of the United States. And there's your high latitude blocking, and maybe your ridge starting to build around Greenland. So towards the end of this period, we start to move towards that direction, but we're not there yet. Let's see. Card says, one observation, just look at 850 millibars. It looks like the cold air at that level is covering a large portion of northern hemisphere as it did last year. So let's go take a look at 850 millibar observations. And we'll do North America. Yep. And it's growing, according to the model guidance. Very impressive. Alaska is just in an icebox right now. Which I guess that makes sense. It is Alaska. What would be the impact if La Niña weakens faster than anticipated? Card, this is a good question. Typically what happens when La Niña weakens faster than what's expected, you get a residue of basically the polar jet stream remaining strong because it kind of feeds back on itself, but you lose the support of the southeast ridge. So you're more likely to get more sustained cold air masses in February than you would normally in a regular La Niña. The fact that it's also east-based would enhance that potential. A clipper that gives us a nice couple of fluffy inches right before Christmas Eve will be fine enough. Flakes in the air with nothing accumulating after once we get that would be perfect. Okay, send it in. I can't control that, but if that's what happens, I'm down. Rob asks, when you say the upper level low, I'm assuming that you mean you're viewing feedback 50-50? Yes. What do you want to look for with major winter storms is an upper level low somewhere around 50 north, 50 west. It doesn't have to be exactly 50 north, 50 west. I mean, if you're 49 north, 48 west, it's not going to be the end of the world, okay? You're still going to get the blocking necessary. But 50 north, 50 west sets up the scenario where you get a strong high pressure system locked into the right around Maine and to the north of New England. And that funnels in cold air towards the coastal plain and keeps your cold air locked in. When do you expect true bitter Arctic air showing up in the northern plains and then spilling east? Usually climatologically in La Niña probably by mid-December. We start to see that start to evolve and then getting stronger with that signal as you head towards January. And we covered all the questions on the premium side. Let me go take a look at YouTube. Holy smokes, we got a ton of stuff here. Wow, okay. Wow, well, thank you, Steve, for the gift. I really appreciate it. Let's see here. From the data you're seeing now, this is from Swirl Turtle. Okay. From the data you're seeing now, what do you think is the most likely scenario for Sunday? I know you went over it briefly already, but I just want a bit more details if you can provide them. Okay, so what I'm generally expecting in this type of pattern is still a progressive fast-moving low because of what we're seeing off to the west. So I really like the idea right now of like just going with scattered snow showers for it right now and maybe a dusting to an inch in some locations. I really need to see more data of the boundary layer. That's the surface, like your car tops, your street level, of what those temperatures are as we get closer to this event to really get an idea of any type of potential accumulation. So you got a fast moving low that is developing, that's intensifying, but it's fast moving. You got a questionable boundary layer situation, but plenty of cold air in the mid levels. That usually, and it's happening, at least for right now, it's happening Sunday night into Monday morning during the coldest part of your daytime period. You combine these factors, I like the potential of maybe our first scattered snow shower event, a dusting to an inch. I don't see support right now for a 2 to 4 inch snowfall like the European showing right now. I would not be surprised if it gets scaled back. I would not be surprised if the model guidance the next couple of days wavers between a mist and scattered snow showers. But I don't like, one thing I can rule out based on the way that the western pattern looks, the pattern over the Rockies, is a major winter storm. This looks like a pesky clipper that comes in and goes out really fast. Let's see here. Let's see. I've been hearing that late winter, like February, is going to be the coldest and snowiest. What are your thoughts about that? That would depend. Okay. Here's what you would need for having that set up. You need La Nina to collapse. I mean, like, die. Okay. Then after that, you would also need the polar vortex to be severely disrupted at the same time to lead to a split. So if you get those factors together, yes, then it would be very cold and snowy in February. I would not promise that because you have far too much in terms of volatility and chaos involved in such a scenario that literally there's no data right now that would support that evolution. But we would know that would be a possibility by the middle of January. Let's see. In New Jersey, you have more sand on the roads than snow. That is very, very true. And then Chris asks, modeling has been bullish on trying to develop a negative EPO. Yes, indeed. But it keeps failing to materialize due to that cool pool of water in the North Pacific. In my opinion, that needs to go away. Not exactly. The cold pool can still remain. The reason why the models are trying to show this negative EPO is because of, where is it? There you go. This feedback here of ozone buildup. Okay. So I think what's going to happen is that as the polar vortex is disrupted, you're going to get a lobe that's going to drop down towards Alaska. And when that happens, you're going to see a negative EPO really lock in. And I really like that towards the end of December into January. That's a theory. I don't know whether that's going to happen. I think it's going to happen. But if we see a strong disruption and we see that warm air come in this area and bisect the polar vortex, I think that splits it, drops this part south towards the Hudson Bay, and you get that evolution take place. And you're kind of seeing the hallmarks of that situation being teleconnected here in the ozone patterns. So something I'm definitely going to be keeping an eye on. It's kind of a little theory I have. I'm still testing it out. I've been testing it out for the past 5 years of using ozone anomalies to try to depict where I think you're going to have your below normal heights at 500 millibars based on mass buildup in the stratosphere. So we'll see if that works. It worked a couple of times. There was 1 or 2 times where it didn't work out, but that was because of disruption in tropical forcing, which I don't think is going to be a factor this time. But we'll see how that plays out. And let's see, we got more questions back here. Cardex, it seems the I-95 corridor east to the coast Even if there are flakes in the air, the surface will be too warm for anything to stick between the urban heat island effect and water temperatures. Yeah, that's typically why I don't like going for snowfall events before December 15th on the coast. And it's also why I strongly suggest not to hope for a white Christmas. It's why it's below 10%. There's just a lot of factors going against it. That low ozone spot in the western United States screams high pressure ridge out there. Very good, Card. That's a very good observation. There's a reason why for that, too, which we'll discuss in the long-range thoughts over the next couple of weeks as we watch that evolution take place. And typically I'm focusing on the ozone concentrations every Friday. So as a premium member, definitely check that out. It's with the solar data, which, by the way, the sun is still very active. So that's certainly something to monitor and keep an eye on. Let's see if we got any more questions. It's 8:46. And we'll see what we got here for questions, if there's anything else. Okay, I think we got pretty much everything answered here. Again, Thanksgiving travel shouldn't be an issue. It's pretty quiet out there. Our last little snowflakes coming off of the Great Lakes are dissipating. Pretty much quiet now. And looks like the Thanksgiving Day weekend, for the most part, is looking pretty good until you get to about Friday morning. In which, in that case, not really. I think Black Friday is pretty much dead. I think you guys would agree with me on that. Personally,
people will still be out.
I don't understand why anyone would go out shopping, especially if it's raining out.
Especially when you can stay home in your PJs.
Yeah, and buy online, right? That's what I'm doing. Hell, we all got most of our Christmas shopping done, so I'm like, I'm out. 2-3 spots a day, but they are fairly quiet ones for active period. Yeah. The sun is definitely look. There are certainly some aspects of the sun that could be more active. This is not exactly the strongest active sun period that we're seeing, which again points to maybe by the time we get to about 40 years out, we may actually see a true grand solar minimum, but we're not there yet. Does the snow extent and depth in Canada support better chances for Arctic air? Yes. Especially since we've seen a rapid growth over the past 2 weeks. It's not the deepest I've ever seen, but it's supportive enough to definitely support those air masses, especially as they drop in from, let's say, the Northwest Territories through the Hudson Bay and then towards the Great Lakes. That's pretty much where I'm focusing the air mass transport right now. I would also keep an eye out for early December of all that cold air in Alaska dropping its way down through Western Canada and then heading towards the Northern Rockies, and then we'll see where it transpires from there. And Card, of course, is going to Borgata on Friday. Of course you are. Well, have fun with that, man. Enjoy and good luck. So I think we are going to call it a night. I'm going to help Susan decorate, and I'm going to help cook. Okay, all right, let me holy smokes. Look at this. Okay, let me see if I can adjust the camera here. There you go. See, there's the tree. It's kind of a thin tree, but it's ours.
It works.
It works for our apartment. Yeah, works for our apartment. When we get a house, we'll get about 4 or 5 trees and decorate all of them because I'm crazy like that. So when I get a house, okay, when we get a house, it's going to be the Griswold house. It's going to be lights everywhere. It's going to be crazy. It's going to be so bright that airplanes are going to accidentally land by us. That's how crazy it's going to be. Guarantee you. But you guys have a happy Thanksgiving. I'm going to call it a night. I'm going to head on out. And I really, really want to thank you guys for, again, buying merchandise. I'm just like floored. I'm really, really happy, and I'm humble, and more is on the way. And I just want to thank you guys for that, and of course for being subscribers and premium members.
Did you show them the mug?
Yeah, showed them the mug. Yep, see, there it is. There's one side, and then there's the other side, and there's me drinking it. Honestly, you guys let me live my dream. So I'm really thankful for you. So thank you very much for allowing me to do this every week, every day. From the bottom of my heart, thank you. And I hope that you guys have a wonderful Thanksgiving, a safe Thanksgiving, and you have, a great time with all your family as best as you can, with family, right? So thank you, and as always, stay safe out there.